Hey everybody, my mini refrigerator just stopped working today. I'm assuming yours did too. But let's go over the steps to diagnose and replace the cheapest parts possible. Today we are all going to become refrigerator repair people. Let's do it. This mini fridge is quite old. It's a Danby DAR259BL. The fridge just stopped cooling, so I just basically diagnosed with a multimeter. I started poking around to figure things out. So underneath here, you see the compressor and the lines, which you can usually tell if it's running because one will be hot and one will be cold. The smaller one will probably be hotter because it's compressing. They're both the same. If it's running, they're both cold, there's probably a problem, or both just normal temperature. All these green ones are grounds. So the first thing is disconnect the power. And capacitors can hold charge, but I didn't see any on here. So there's a clip like that. You just snap it up and it falls off the bottom. Looks like that. You just snap it above the little groove. This plastic housing pops back, and these will be hot, so make sure it's unplugged. And see, I can't get this out, so I just tuck it away. Anyhow, this first one's the relay. So I'm just going to take this. You could test these, so that's what I did first. Is if you look on the back here, there's a diagram, and you'll see that the thermostat is circled, the PTC starter, which I'm guessing is the relay, and the compressor. On the left you'll see the plug, power plug, and then there's a neutral, and then the E is to the yellow-green, which is also just a ground. The neutral's white, and then the L, which is black, is the power wire. So that's all you have to know. And then the red wire coming off the thermostat is once the black power goes into the thermostat, then it comes out when it's regulated what voltage, and the red wire will go to the overload protector, which is the little metal-shaped disc that will just heat up and expand and disassociate the flow of electricity through and then turn off the compressors. Those three things are all that I can really tell from this. So you're just going to trace that pattern back. So that's a neutral wire, the white, and then the green right here is a ground to this port, and then the red in the back is to the overload protection coming from the thermostat. But I don't need to disconnect that. What I was going to do first is test this relay. So all I just did is put a flathead and gently pry it out, because it just sits on these two prongs. The third prong on top here to the compressor is getting from the overload. So once the power goes through the thermostat, it comes out in the red wire, and then goes into this overload circuit. And if the overload circuit is not overloaded per se, it will come out with this black wire going to the top of the compressor here, giving it power. And the green is connected on the other side. First I checked this relay. I mean, usually mechanical stuff can shake it. Didn't have any noise, that's a good sign. So you can test it for resistance. So I took my multimeter, I put it on. There are two little ports in here, and I'm going to take the probes and just put them gently in each port. So first you can test for continuity, so I'll swap this to the continuity. So if you swap to the continuity, that little looks like a Wi-Fi symbol, because all three of mine are on the same port, the ohms and the continuity in the other one. So you can touch them and you'll know it's continuity between the two. Then you can do that here. So there's continuity. And then also, I'll switch it over to ohms, which is the omega symbol. And then you can just do that as well. And I believe these read at 5. So this one's still good, 5.4. ohms, not kilo ohms, not anything else. So the relay on this was good. That's what I started with. And I know a lot of people, at least I believe, replace the relay and assume that's it. The overload protection is, since it's just a piece of metal, I'm not going to mess with it. Also, if you look close in there, it's not very easy to get off. It's got little metal clips, and I'm going to have to... Actually, it is easy. Now that I view it from this side, you just squeeze those tabs together and it pops right out. But that was a last resort, so I didn't end up needing to do that. On the back of this fridge, sometimes the thermostat's inside the fridge, but the back of this one had a metal plate like this. It's just got 4 Phillips screws around the edges, so you can see. So I just removed that, and remember, this wiring diagram says that the black wire will be the hot one, so make sure the power's off. From here, I guess for purposes of showing how it was, the thermostat sat like this, and this was coiled pretty symmetrically around it, and that sat on top, and then that went through the little hole on top here, and then on top, then you just push the, it's got one-sided groove. It's flat, so you just push it on here. This is the adjustment for the temperature, and what I think this does is just regulates voltage to send through to determine the temperature, and then send how much to shut off on the little overload. It's connected on bottom as one piece, so theoretically you probably could just cut this and weld this on if you're... In fact, I don't even know what this metal is. Maybe you could solder it. Kind of feels like solder. What I did here is, while these were on, so the red went in the front here. The red goes to the... Okay, this is kind of important, I should say. So this is not stated a lot of places. So there's a C, an L, and an H. The C is on the top left, L is on the bottom left, and the H is on the middle right. And there's kind of an indentation there. And the L is missing. There's only 2 ports on this. So, but the point being is that you can get a replacement that has this 3rd port and just leave it undone. But don't touch it, because it will probably, you know, electrocute you once it's done. But it will be covered by this metal plate, so you should be good. Now, upon searching which one to swap it out with, I looked, and basically you just get the same model that bolts up. So what you want to look for is the 2 screw holes on the top, like that. And then the green wire is sitting here. Now, on this unit right here, it's sitting in the back, but on the other replacement one from Amazon for 10 bucks, it's sitting on the front. That shouldn't matter, because that's just a grounding point and won't really matter. What matters is these 2. So this is a WDF 23.5K-102-124A, right? What you really need to focus on is the WDF, because I believe that's the location of these C and H channels right here. And it has to do, I'm not exactly sure, but it has to do with when to shut off when to auto shut off and restart certain functions of the unit. So if it just has a WPF, like some of the ones do that only have 2 ports, it actually has it on the C right here in the L instead of the C and the H like mine. So the PF and the DF are what you want to focus on, not so much how many ports. So I'm going to get the one with 3 ports, and I'll post a link. I believe it's $10, and what I'll do is just leave the L port gone and just plug in the C port and the H port. So on this one in particular, the power wire that's coming in from the unit, which if you want to test this too for continuity, you can take you just look at the schematic. It's saying black is coming in from the plug, right? So on the plug you'll have ground down here, and you'll have power coming from here. Actually, one will be neutral, right? But back to continuity. Okay, so change it to continuity. And I'm going to stick one here in the black. I'm going to touch the... So on this plug, you'll have the bottom be the ground. One of these will be a neutral, and you'll just touch one of the top 2. So now, nothing. So you know it's not shorted. I guess you could do this too to make sure nothing's shorted, but you know that that's getting power through to the to the main unit. So it's coming from the wall, because this is a 110 volt in the US, 120, and coming through here, and then it's going into the H port on the thermostat. So the power goes into the H port, and then the power comes out of the C port, which is going to the overload. C, I don't believe, stands for compressor, actually. I think they're different, but I'll have to look it up. And H stands, I think, for heat. I don't know, but I just glanced at the diagram and I'm trying to remember. But yeah, so just make sure that those two go in the same port, and then the ground here just plugs onto the plate like that, which you can see is obviously a giant metal plate and not going to attach to any power. So as long as you have that same configuration and the same bolt pattern, as long as it bolts here, it may look slightly different, but you can just use those two ports. I think on regular fridges you can just take the thermostat line, which is a wire that goes inside, and just pull it out, which you can on this one. But what I'm going to do is, just to be safe, because it looks like someone already stripped the screws inside where the actual cooling coils go, I'm going to check it out. So I'm going to go inside and undo some things before I pull it. But I just gently pulling, I can feel it pulling out. So, but just to be safe, I'm going to go in there and do that. All that's holding in the thermostat is a screw on top, there, really simple, and then it's just coiled. This will just sit in kind of a perfect coil. The new one will come in a perfect coil, so really worry about that one. But to figure out why it was the thermostat, okay. I guess that's the important part. So with the thermostat, with the power plugged in, I was just on voltage. So I turned the meter to voltage, and I was testing. So I put one lead in a ground. I mean, you can put it anywhere. You can stick it in here, but this is connected to this actually. So basically, you can just touch this, and you'll have to do it when it's bolted in. Obviously, you do not touch this with your hand when it's hot. You'll never touch any of this stuff with your hand. So you would touch this, what's sitting up there, and then you can touch the one coming in. Boom, I would do that, and I was getting 116 volts. I thought, okay. And then here I was getting all kinds of weird fluctuations over time, but ultimately I was getting 7 volts. I thought, okay, that just seems really low for it to be pushing through if this regulates voltage. And then what I did is, well, this is bolted in. This can just be, taped on here. And so all this is being held in. You just touch this, and then you can turn the knob. And turning this knob should regulate the voltage to a different level. It was not doing anything, so that was another sign. So I thought, maybe it's this. So what I did is I disconnected the power, then I took off the thermostat, and then I kind of pulled the sheathing back a little bit on both, laid them together, and just put a piece of electrical tape around there so the metal is touching. And then I plugged it in. Boom, compressor kicked on. And just to make sure nothing else was the issue, I let it run for 10 minutes just to make sure it wasn't going to shut off or the overload. The overload wouldn't have kicked in yet because at least that I think, because the fridge was not running that long. And I think the overload is like a default. It would just kick off after a long period of time. So let's say the thermostat was faulty, the overload would kick in as a secondary. But the thermostat actually is supposed to regulate the voltage, so it would cut it here after this wire feels that the temperature is, say, 30. I think these are supposed to be 35 degrees. Anyhow, so yeah, so that's it would come through here and sense that, then it would cut the voltage here first. But anyhow, 10 minutes is fine, and I don't recommend shorting these and then running this indefinitely because your overload would probably break over time. So anyhow, that's how I came to the conclusion that it was the thermostat. Luckily, the fridge didn't have anything in here besides drinks, mainly. What you can see back there is the coolant lines, the condenser coils running through here, so you don't want to dent these with anything, but these screws are stripped a little bit, so I think this has been removed before too. So the thermostat has probably already been changed at some point. It's just 4 screws. I'm just going to take a peek to see carefully if there's any sort of hook for the thermostat, so I'm not doing any major damage to it by pulling it directly out, which I don't think I am, but I'd rather be safe than sorry. the thermostat, the exact thermostat replacement from the company is $50 and back ordered, which probably means it doesn't exist anymore. So definitely go the $10 route. It's not worth replacing for more than that. It's a good thing I checked it, because the thermostat, so this line right here, you have to just gently, it will just gently bend a little bit and you bend it back. But the thermostat's right there, that off-white. I can't even see what I'm doing. I'm looking to the camera now, but it basically clips around this. Nope, it clips through it. I'm gonna bend this down because it looks like it was looped around, and then just pull it up through it. Okay, so that released the thermostat. So yeah, I would recommend pulling that out. It slips right into that. Slips right into that port right there. And then it bends down and it folds up by about 2 inches or 3 inches or so. And you will put that sheath back on, so keep that white sheath. And try not to bend this line too much more than you absolutely have to. I'm actually going to leave it bent out for the time being. I'm going to pull this out now. So there's some black sort of goop stuff around here to seal the hole, but now that it's free, I'm just going to gently pull it out. So remember, I marked it right here where it was into the fridge. So all that was in the fridge, wrapped down right here, and then looped up right here. This one right here had about, it was maybe almost halfway. Half inside, maybe about 40% inside, 60% outside. That's my guess. And the outside was looped for space, I guess. As long as you don't snap this wire, should be good to go. Just another quick thing, if you're trying to troubleshoot other things, and it could be the relay and whatnot. First, you can test for continuity between the wires. So again, use your voltmeter. So if you know the red wire right there is coming out of the thermostat, you just connect one lead. There's 2 leads. Connect one to the red wire up top at the thermostat. Just touch the metal, and then just touch right here. Okay, so it's beeping, so that's got continuity, right? And then you can touch here, where it comes out of the. If you want to see if your overload circuit is having a problem, you can take one lead here coming to the black wire off the bottom of it, and then touch the other lead to the red back there. So I'm touching to the red going in, and I'm touching to the black coming out. It's a closed circuit right now, so it's got continuity. So that's a good way to look at the overload protector to make sure it's not tripped. And then if you want to test the, let's see, the neutral wire, you can just touch that. And sorry about the light. I'm trying to get this at a better angle. Okay, so I'm touching one port here. So one of these is the power and on the 110 volt, and the other one's a neutral. So I'm going to touch the one that I remember is not the power, and then I'm going to touch the neutral here. So that's getting continuity too. I'm touching the ground wire here, touching the base ground here, and then touching the green. Oh my, no wonder it's beeping like crazy. Died. Okay. So I'm touching the ground here and the green and yellow wire. There we go. Okay. So you can do that to test the circuits to see if they're getting through. Now on the relay, only getting that, and it's going into that, so let's see. Not exactly sure. If you touch the... Okay, so is it showing with the light still? So if I touch the relay, the white wire on the relay, and then touch the top pin here, it's got continuity. I don't know if that's perfectly correct, but at least we know that there's some voltage going through the relay to that. That could be another sign, but I still recommend taking off the relay and testing it for resistance and whatnot by itself, and shake it. Usually you can just shake it and know that they're bad. Now, if you plug it in, which I don't recommend unless you know what you're doing with it live, because this is hot. But you can also do the same thing and check the voltage. While this is plugged in and hot and bolted in, right here, you wouldn't touch this with your hands at all, but you would put one pin. You put one pin here. So you put one here, and you'd put your meter on voltage, AC, and then this would be bolted to the thing, so you wouldn't touch it, wouldn't get electrocuted, and then basically you touch the port coming in here, in the back here, and it would say 116, mine did, or something around those lines directly coming from the wall outlet, and then you touch the port here, and you expect it to say something very similar, because if the fridge is hot, like mine was, it should be kicking on and not restricting any voltage. And then if that's way off, like my front pin here was 7, so that's quite a big difference. No wonder it wasn't kicking on the compressor. And then if yours is really similar, let's say it's 116 and 113 or something, it's probably okay, but it's still, you're still not sure. You can leave this lead in here and then twist the knob on top with the plastic. This will be bolted in on top, but you use the plastic here and it just stops. You can twist it and see if there's a voltage difference between the two. There should be a significant difference when this twists. Also, I believe this top part only adjusts in increments of probably a couple degrees overall. I'm not exactly sure, but this screw right here, this little screw, it's a tiny little Phillips. Is it showing? Hopefully that's showing on camera. That one adjusts the overall temperature. So if this is freezing or heating or not cooling enough, on the new thermostat, you'll twist this and test it. And I believe it gets to a point where it has a reset and can create an issue, so don't go too far. Just do small increments and then check it. You can also get one of those thermometers and stick it in your fridge from the dollar store, and it will say the actual temperature. And just try to regulate this in maybe half turns. But if you just screw it and do that, you might mess with the internal settings on this one specifically, because I don't know if the WPF has the reset thing, or I'm not saying it right, but the one that cycles and then resets, something like that. I think the WDF is specific because it does do a function similar to that. A little confusing, but basically just adjust it there if you're having issues. The way they come stock maybe will work though. Put it back in. So just remember the orientation that it was in, but there's just 2 pinholes on this, and then you just put them back on the 2 pins. 2 pins right there. Just okay, and just push that on like that. And put the neutral wire back on there. Boom. That power wire in the back doesn't go on there too tight, but that's it. Just put the case back on. This particular fridge, there's a port right there for the wire harness, and other than that, just clips around the back, and it goes underneath this hook here, because the metal thing hooks on top, and that's it. And then if your fridge is as dusty as this, clean it. Plastic cap back on. What I did is I just pushed the metal tab, so I pushed it in this bottom corner here. Right here, I pushed it in this bottom corner, and I'm just holding my finger, and it's hovering on top. Sorry, like that. So now I'm just gonna, while holding on the bottom, I'm just gonna stick my finger in here, and that's it. Snap it in. Damn this light. Okay, and then it's on there. So just snap in the bottom. It's just, if you push this bottom corner like this, it will just automatically find its way into the groove on the bottom. And then just fix the one on top. That's it. Done. So this is the WDF 20-L, the new one. This is the old one. The WDF 23.5K. This says it will do the WDF up to 25. They don't make this in between 23 or 24 anymore, apparently. And you can see that the ports here on the WPF models, they'll have the ports on the same side for the functionality, and on the WDF they'll have the ports on the opposite side for the functionality. So, but again, really what matters is the hardware on top. And these are opposite, but that's okay because it's just a grounding point. This one's not as long, but it should be long enough. I'm going to unsheath this line here. Just pull this off. It's got this tapered tip here, and you can see the bend where it actually bends around that loop, which will probably be shorter on this new one. The end is rounded off, so it shouldn't cut through anything. The wire feels like solder. If you've ever felt solder, it feels very weak, so just be careful because I feel like I'm going to snap this thing. Just putting this sheath on. Maybe you can use WD-40 or a little bit of Vaseline or something to put on the metal, although I'm not sure the effects that might have. Probably nothing. But I was not able to get the sheath past this point on the original. But it's okay because I left this sealed, and really this can just fold around. There's lots of space in there, and this will just be the end, and the new fold will be here somewhere. Because there was actually lots of excess outside last time, so as you can see now, this sheath went to here. The old one went further, so this is where it went. And then actually you can see the black mark where this sealant was, and that will just be a little bit further, so it's not a huge deal. Feed it through the inside. So there's the original point, so I know it's probably going to be a couple inches more. Carefully pull this out. I'm just going to feed this. See, this is excess right here. This is just plastic, but the metal stopped here. So I'm going to put the metal past where it was here and then bend it up. So you will definitely want the metal here, touching here. I'm not going to cut that because it's actually sealed. So I'm just going to take the 4 screws, bolt that back in. It ended up being pretty similar. I'm just going to reuse this sealant here, but realistically you could just use some silicone. You can get a small tube of silicone at Lowe's for $2. A lot of people have silicone laying around. That will seal this, but this is kind of pliable stuff if it's on yours. And I'm just going to bend it back around and seal it. And then this, fortunately I kind of damaged the wire a little bit. So you just need to make sure this is, round enough to fit in the box, so I'll just have to adjust it probably this way a little bit, but you don't want the metal from this line to touch any of these. So remember, this is the black, according to this diagram, is the one coming in. I'm gonna place that here at the back. Well, it's a little loose, because these are different. I'm going to just squish the pins on this a little bit. And then the red went to the tighter. Went to the one labeled L. And this one goes here. I'm going to make sure the little sheath for the insulation is up on there. Tighten a little bit. It looks like this pin here. Just a little bit though, because if you do too much, we'll have to bend it back out. Also, this could be live, so I'm going to tape that off. But just make sure this roughly fits. Okay. One little side note, when you put this on, you can only go one direction, but the nice thing is that when you put the arrow to 0 right there, it actually just clicked perfectly. It was exactly built for it and stops right there, so it is a, I believe as long as the hardware lines up, these are universal. So yeah, just make sure you have the sealant stuff actually sealing the hole quite well, and make sure these are nice and tight and not loose, covered, and then tape this off. And you will have to adjust the small screw inside of there if this is too hot, which it could be. Of course, Amazon stuff is written so poorly, you never know what to expect, but that's it. Made sure don't touch anything, but just plug it in, and you can hear that the compressor actually kicks on now. So, good to go. Although you have to play with the adjustments after that, but this particular fridge is fixed. Yay, good luck to you.